everyone, how are you today? If you are watching this video for the first time in our channel, please don't forget to subscribe to our channel, and those who are watching our series from the beginning, so it is the Sankalp KCET 2026 series, and I am going to solve the previous year questions from the chapter electrostatic potential and capacitance, right? So we have already covered the chapter in 3 parts. So if you have missed those parts, please go back and check those parts. They are specifically curated for KCET exam preparation as well as your board preparation. Somewhat basic concepts and in-depth concept building part is done. So if you have missed that, please go and check that out. And today I am going to discuss all the previous year questions from this chapter 30 PYQ questions. Not all, obviously there will be a lot of questions, but 30 questions from the last previous years, including 2025 questions that came from this chapter. So everything is covered in this video. You don't need to go anywhere for the previous year questions from this chapter. And if you want to download the PDF of this chapter, then you have to join our WhatsApp channel. The link of the channel is given in the description, right? So also the students who have followed us since last year and they have achieved an excellent result, you can check their result that we are showing in each and every video. And you might be wondering why we are showing. So there are a lot of students who are following us from the beginning, but only few those who followed us from the beginning and throughout our series, and they have achieved excellent result. So to achieve that excellent result, you have to follow us from the beginning. Each and every lecture you have to watch. Maybe if you don't have time, you can fast it forward 2x speed, and then your picture may be next year on our leaderboard, right? So let's start with the first question, and this is from KCET 2025. A potential at a point A is -3 volts, and that at another point B is 5 volt. What is the work done in carrying a charge of 5 millicoulomb from B to A? So let's see the question in a picture so that you can identify it. So we have the point A at -3 volt, and we have a point B at +5 volt, right? This is given, and the charge is given here 5 millicoulomb. So charge is 5 millicoulomb, means 10 to the power of -3 coulomb. Okay, so these things you have to be very familiar with. Now it says that you are moving the charge from B to A. So you are moving the charge from B to A. So what is your final position? Final position is A, initial position is B. Now what is the work done? To calculate work done, we know that the potential energy is at a point. Potential energy at a point, say P, the voltage is V, charge is Q. What is the potential energy at P? Potential energy is Q into V, right? I have discussed this again and again. So potential energy at a point is given by Q into V. So what is work done? Basically work done is basically change in its potential energy. Whatever change in its potential energy, that much work has to be done. So what is the initial potential energy? Now for the beginning I am doing it little slower, explaining each and every terms. As I progress throughout the questions, once you are more acquainted, then I will not do all the steps. I will might skip some of the steps. So first few questions, please bear with me so that those who are little weaker, they can also understand. So potential, and now what is the work done? As I said, potential energy at the end, final potential energy minus initial potential energy. Sorry, just excuse me. So initial, final minus initial. Always remember, it is always final minus initial. Okay, final potential energy minus initial potential energy. Now charge is constant over here. Okay, so charge is constant. So what is the final potential energy? Final potential energy is Q into final potential, Q into VA. And what is initial potential energy? Initial potential energy is Q into VB, right? So this is the potential energy. So Q is common, so VA minus VB. Now what you have to do, you have to just put the values and calculate. So what is the work done? So work done is Q value is this 5 into 10 to the power of minus 3. What is VA? VA is minus 3. What is VB? VB is 5, but there is a negative sign over here, that's why it is negative over here. So it will be 5 into 10 to the power of minus 3 into minus 8. Right, this minus sign will be outside. 5 8s are 40 into 10 to the power of minus 3, or it will be 4 into 10 to the power of minus 2, or minus 0.04 joules. Okay, 0.04 joules. So correct answer option D. Now next question, match the column 1 with column 2 related to an electric dipole of dipole moment P that is placed in an uniform electric field E. Okay, so P and E, what is the matching that we have to do? Angle is given, angle between P and E, potential energy of the dipole. So potential energy of the dipole, which is very, very important. So if you remember, when we place a dipole in a particular point, the potential energy is given by, potential energy of the dipole is given by minus PE cos theta, minus PE cos theta. So there is a negative sign over here. So what is the first angle? First angle is 180 degree. So minus PE cos 180 degree. Now here we have to remember that we assume that cos 90 is 0. So that is our starting point. So from there we calculate everything. So minus PE cos 180 degree means minus 1. So it is P into E. Okay, so for 180 degree the potential energy is PE, so that is number 2. Now for 120 degree, again same formula, this say U1, U2 will be minus PE cos 120 degree. Now what is the value of cos 120 degree? Cos 120 degree is PE into minus half. Cos 120 degree means minus cos 60. You have to remember all sine, tan, cos. 120 is in the second quadrant, so cos will be negative, and cos 120 degree is exactly equal to cos 60 degrees. I have discussed everything in my bridge course video. So if you have not seen, there are 2 parts of the bridge course video for you to get familiar with all these geometrical beginners. So U2 is half PE, so from here we get this, and obviously cos 90 energy is 0, PE cos theta, cos 90 is 0, so from here this is simple matching. So A is matching with 2, B is matching with 3, C is matching with 4, so option C is correct answer in this case, 2, 3, 4, right? Now this is also from KCET 2025. Which of the following statement is not true? Very, very important to remember, this is not true. Not true, incorrect statement. So incorrect statement means if this is say which of the following is true, that means one statement is correct. Here which of the following is not true, that means 3 of the statements are correct, only 1 is incorrect. So basically they are trying to ask you which of the following statement is incorrect. So this is a way of saying. Okay, so you have to identify correct statements, and from there you have to separate the incorrect statement. Equipotential surfaces are the surfaces where the potential is constant. That is the definition of equipotential surface. Surface of constant potential is called equipotential surfaces. Equipotential surfaces for a uniform electric field are parallel and equidistant from each other. For uniform electric field, equipotential surfaces are parallel and equidistant from each other. So this is the definition of equipotential surface. Second one is also correct. Okay. Electric field is always perpendicular to an equipotential surface. So if you see that electric field is always perpendicular to the equipotential surface, maybe spherical, maybe plane, it is always perpendicular. This is also a correct statement. Work done to move a charge on an equipotential surface is not zero. So we know that work done to move a charge in an equipotential surface is zero. It is always zero. Work done to move a charge in an equipotential surface is always zero. But here they have mentioned not. That means this statement is incorrect, and in fact this is our correct answer. Okay, because we are trying to find not true statement, so this statement is not true. So this is the correct answer for our given question. Now this is a question from KCET 2024. If you see that, this is also a similar question, but here they mention that under electrostatic condition of a charged conductor, which among the following statement is true? Previous one was not true. Okay, so true and not true type of question is very common from this chapter, as you can see. So this is a very easy question, easy standard of question. If you read it properly, you should be able to answer them. So don't get carried away by saying that there are a lot of difficult questions, but these questions are actually easy to answer. You just have to remember few facts and understand the concept in depth. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught. Now if you remember, the electric field on the surface of a charged conductor is not sigma by 2 epsilon naught. It is sigma by only epsilon naught, not 2 epsilon naught. If I have explained it also, only for charged sheet, infinitely long charge sheet, this is given by sigma by 2 epsilon naught. For conductor, it is sigma by epsilon naught, not sigma by 2 epsilon naught. Okay, so this 2 factor is incorrect for a conductor. The electric potential inside a charged conductor is always zero. Electric potential inside a charged conductor is not zero. Electric potential is constant. Okay, so there is a difference between constant potential and zero potential. Okay, you cannot say constant to be a zero. It can be zero. Obviously, if it is uncharged, then it will be zero. But if it is charged, potential will be constant. That will be a non-zero constant value. So this statement is also incorrect. Any excess charge resides on the surface of the conductor. So if you give a conductor some charges, the charges will always float like objects float on water. Okay, so it will always stay on the surface. So any excess charge will always stay on the surface. No excess charge can stay inside a conductor. So this is the correct statement, and in fact this is our correct answer. You can check the last one as well. Net electric field is tangential to the surface of a conductor. Net electric field is not tangential, it is perpendicular. Okay, it is not tangential, but it is perpendicular. Okay, this is tangent. Okay, and this is the electric field. So this statement is also incorrect. Let's move on to the next question. A uniform electric field vector E exists along the horizontal direction as shown. So here we have existing electric field as shown. The electric potential at A is VA. So it is given electric potential at A is VA. Electric potential at B is not given. A small point, the electric field is given, by the way. The electric field is given. The distance x is also given. Okay, if it is not clear, I will write it bigger font. A small point charge Q is slowly taken from A to B along the curved path as shown. So it is taken from A to B along this curved path as shown. Okay, the potential energy of the charge when it is at point B. So what is the potential energy, not potential? Remember, potential energy at B. What is the potential energy at point B? So if you are following me from the first question, then you should know that electric potential at any potential energy at any point is basically charge into electric potential at that particular point. This is how you can calculate electric potential at a particular point. So VB is not given, so we have to find VB from the all other information which is given in this question. So how to do that? What formula, what equation we will start with? So if you see, electric field is given, potential at one point is given, and the distance is given. So what is the relationship between electric field and potential? We know that E is equal to dV by dx, right, or delta V by delta x. Now what is the meaning of dV? dV means is the potential difference. dV, there is also negative sign. So negative sign is important in this case. You cannot ignore the negative sign, because based on that your answer might change. So you have to add that negative sign as well. And how to find dV? dV is final potential, always final potential minus initial potential. This is how you calculate the potential, divided by the distance. Distance is x over here, so you just divide by x, right? Now let's calculate. So VB minus VA equals to minus EX. We just cross multiplied, and my negative sign from this side I have taken it to the other side. So VB is basically VA minus EX. Okay, this is the electric potential at the point B. Okay, so now what is the work done? So work done will be Q into VA minus EX. You have to remember that electric potential decreases as we are moving in the direction of electric field. So as we are moving in the direction of electric field, electric potential decreases. So it has to be VA starting point minus EX. Okay, so if you remember this also will be helpful. So this is the correct answer, because lot of wrong answers are given. If you have not taken this negative sign, you would have got one of the wrong answers. Okay, EX plus VA, you should have got that. Okay, so be careful with the sign whenever it is required. Okay, if it is talking about magnitude only, then you can ignore the negative sign, right? But here the negative sign is very, very important. Now next question, this is from KCET 2026, slightly formatting error, sorry for that. A parallel plate capacitor of capacitance C1 with a dielectric slab between its plates is connected to a battery. It has potential difference V1 across its plates. When the dielectric is removed, the potential difference are C2 and V2. So this question I have done in my live class. If you are following it, you should know that when we are connecting a battery to a capacitor, the battery's only duty is to charge the capacitor up to the potential of the battery. So if the potential of the battery is V volts, then after some time the capacitance will also reach the same voltage. Okay, so the capacitance will reach to the same voltage. Now if you have kept the battery connected, no matter whatever is inside the capacitor, the voltage will always, the final voltage will always match with the final initial voltage. Okay, so if the battery is kept connected, if the battery is removed, then something else will happen. We will see that in a while. There is a question based on that as well. But when the battery is connected, then you have to remember that the voltage across the capacitor, no matter whatever inside, if there is a dielectric slab or not, the voltage will remain the same. How it is happening? Because the charge will change. Q is equal to CV, right? C is constant. Now we are making V also constant. So capacitance is changing. Capacitance is not constant. Capacitance is changing. So capacitance changing means only thing that can change is the charge. Voltage, if you are keep constant, then charge stored in the capacitor will vary. Okay, so basically dielectric constant means if you add a dielectric, it can store more charges. If you remove the dielectric slab, less amount of charge will be stored. So this is the very basic fact. So what they are talking about? So initially voltage was V1. When the dielectric is removed, final voltage is V2. So V1 has to be equals to V2. There is no other option. So V1 has to be equals to V2. What else? So initially capacitance was with a dielectric, right? So and the final is without dielectric C2. So basically we can say that C1 is equals to K into C2. K is the dielectric constant. Okay, K into C2, because initially it had a dielectric medium in between them. So obviously we can say that C1 is greater than C2. With dielectric, capacitance is always bigger. So from there we can say that C1 is greater than C2. Okay, so correct answer is V1 equals to V2 and C1 greater than C2. This will be 2. Okay, C1 is greater than C2. So let me correct it. There are options are slightly incorrect, sorry. Okay, so C1 is greater than C2. Okay, now let's move on to the next question. The electric field and the potential of an electric dipole along its axis vary with the distance r respectively as. So electric field and potential. Electric field and potential due to a dipole on its axis. How? Electric field varies? Electric field varies as 1 by r cube. If you remember, electric field varies as 1 by r cube and potential varies as 1 by r square, 1 less. This is always the relation. So E is proportional to 1 by r cube and potential varies as 1 by r square. Two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges is. So this is a potential question. So far we have seen most of the questions are based on dielectric, capacitance, etc. But this is a simple potential based question. Two tiny spheres carrying charges 1.8 microcoulomb and second one is 2.8 microcoulomb. They are separated by a distance of 40 centimeter. We are trying to find potential at the midpoint. So what is the distance of the midpoint from this charge? Obviously 20. And what is the distance from this charge? Obviously 20. And everything is centimeter. Okay, remember this distance is in centimeter, right? Because you have to convert it. Now what is the electric potential? They are asking about electric potential. So what is the formula for electric potential? Net electric potential. Net electric potential is basically, if you take V1 say this is 1, so V1, and this is say 2, so V2. So net electric potential will be V1 plus V2. Simple as that. So what is V1? V1 is KQ1 by R. And what is V2? KQ2 by R. So R is this 20 centimeter. Because they are equal, midpoint, so distance is equal. So that's why I have assumed both distances to be R. Okay. So K by R is common. What is Q1? Q1 is 1.8 and Q2 is 2.8 and it is in microcoulomb. So you have to be careful. Micro means 10 to the power of minus 6. So let's continue. put the values. V net equals to K is 9 into 10 to the power of 9, and this turns out to be 3.8, 4.6. 4.6 into 10 to the power of 4.6 into 10 to the power of minus 6. And what is division? Division is 20 centimeter. So 20 centimeter, as I say always, convert into meter by multiplying 10 to the power of minus 2. You have to remember this small conversion. Okay, now if you see that you can cancel this 10 and 2.3, right? 2 cancels. Now 10 into 10 to the power of minus 2, what we will get? 10 to the power of minus 1. This 10 to the power of minus 1 once goes up, it becomes plus, and it gives you 10 to the power of 10, right? So this, understand this, 10 to the power of minus 2, it gives you 10 to the power of minus 1, but that is in the division. So that minus 1 goes up, becomes plus, so it gives you 10 to the power of 10. And 9 into 2.3, 9 into 2.3 is 9 to the 18, 3 9s are 27, 18 plus 2.7. So 18 plus 2.7 is 20.7 into 10 to the power of 9 plus 1, 10, 10 minus 6 is 10 to the power of 4. 10 minus 6 is 4. Now if you see that, is there any option like this? 10 to the power of 4, all the 10 to the power of 4 options has much lesser value. Okay, so we have to go to the 10 to the power of 5 segment. How to do that? To go to 10 to the power of 5, we can shift one decimal, and now see 2 into 10 to the power of minus 10 to the power of plus 5. So if you see that, there is an option which is very close to our answer. So this should be our answer. 2.07 into 10 to the power of 5. If you round this number to one decimal, then it will become 2.1. Okay, clear? Now next question. A parallel plate capacitor is charged by connecting a 2-volt battery across it. Okay, then it is disconnected from the battery and a glass slab is introduced between the plates. Which of the following pairs of quantities decrease? Now let us understand this question first. It is similar to the question that we have solved, but it is actually in the reverse order. So in the previous case, the battery was connected and glass slab was removed. In this case, initially the glass slab was not there, the voltage was connected. So when the voltage is connected, the capacitor reaches to the maximum value, that is the voltage of the external source. But now the battery is removed. Now the battery is removed, and then you add a glass slab into this. This is a glass slab. Now you have inserted a glass slab into the capacitor plates. Okay, so first you have to understand that this is an isolated system. Okay, so it is an isolated system means the charge will be constant. The charge inside the capacitor will be constant in this case. Okay, so charge will be constant. Now what will happen to the capacitance? As you are inserting a dielectric slab, capacitance will increase. Capacitance will increase. Suppose this is K. So the new capacitance will be K times old capacitance. So capacitance is not decreasing, capacitance is increasing. Charge is constant. But we know that Q is equals to CV and Q will also be equals to C dash V dash. Right? Because charge is constant, these two equations has to valid. Okay, C is the initial capacitance, initial voltage, C dash is the final capacitance, and V dash is the final voltage. So as you can see that C dash is increasing, this is constant. Okay, C dash is increasing, by K times, the voltage has to decrease to match that increase, because your left hand side is constant. If any one of the quantity is increasing, the other quantity has to decrease, right? So voltage is decreasing. So one thing that you can say, that potential energy is decreasing. Okay, now as you can see that there are only two options with potential difference. So this option and this option. Okay, now as I said, charge is constant, so definitely charge is not decreasing, so potential difference and energy stored will decrease. Okay, so I can give you the explanation for that as well. What is the initial energy stored? Initial energy stored is half into Q into V. Half Q into V. What is the final energy stored? Final energy stored is half Q into V dash. Now Q is constant, so V dash decreasing, so V dash decreasing means the final energy will also decrease. Okay, so this is the question, and if you understand the deeper meaning of adding a potential, removing a voltage source, adding a voltage source, if you understand the deeper meaning, you can answer such questions easily. Now let's move on to the next question. If a slab of insulating material 4 into 10 to the power of minus 3 meter thick is introduced between the plates of a parallel plate capacitor, the separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meters. To restore the capacity of the original value, the dielectric constant of the material will be. Now for that I am going to teach you a new shortcut formula. So this thickness is called dielectric thickness and it is denoted by symbol T. Okay, and you have to remember that T by K equals to T minus X. Okay, T by K equals to T minus X. What is T? T is the dielectric thickness. What is X? X is the extra space that you have to create to keep the capacitance same. Okay, so this is the formula that you have to remember. Okay, there is a small derivation for this formula as well, but I am not going in that derivation, that is not part of the syllabus. So you have to remember, only one question came based on this formula in your KCET history. So if you want to remember it because there is a less chance of this question coming, but this was not super old as well. Last 4 years back this question came, so maybe there is a chance that this type of questions come in your 2026 exam as well. So let's be prepared. Write it down in your notebook for the chapter. Once I give you the once the entire all the chapters are done, I am giving you the final formula sheet, that this formula will be there. Okay, so what is T? T is 4, K we don't know. Now here what is a good thing about this is we are not using this 10 to the power of minus 3 because eventually all the terms has 10 to the power of minus 3, so that will be common and cancelled. Okay, so that's why I am not using that 10 to the power of minus 3. So be smart in such calculations. Okay, 10 to the power of minus 3 anyway will cancel. So 4 minus 3.5 is 0.5. So from here we get that K equals to 4 by 0.5, that is 8. So dielectric constant is a dimensionless quantity and its value is 8. Next question, 8 drops of mercury of equal radii combine to form a big drop. The capacitance of the bigger drop as compared to the smaller drop is. Now for this there was a part where we used to learn about spherical capacitor. This is not there in the syllabus, but this is a very basic question. You have to remember that capacitance of a spherical capacitor is proportional to the radius of the capacitor. Okay, proportional to the radius of the capacitor. Okay, that is the only thing that you have to remember, nothing else is required. Okay, spherical capacitors, bigger the radius, bigger is the capacitance. Okay, there was an interesting question that if you want to build a spherical capacitor of capacitance 1 farad, the radius has to be bigger than that of the earth. That was one of the favorite question that used to come when I was a student. Okay, anyway, so here the spherical capacitor, it is proportional to radius. So if small drops of mercury has a radius, say small r, okay, small 8 drops, 1 2 3 4 5 6 7 8, once they combine to form a bigger drop, the radius say r. Okay, now there is a shortcut that you have to remember. Whenever drops are submerging, the spherical drops are submerging, the q of the bigger radius is given by number of drops times small radius cube. Okay, if you see that, most of the time it will be given as 8, 27, like that. Why? Because cube root is easier, nothing else. So r is 2r. So radius becomes double. So double the radius, double is the capacitance. So capacitance will also become 2 times. Okay, this is as easy as this. So if you add 8 small drops of mercury, the capacitance will be 2 times. Which of the statement is a false in the case of polar molecules? So polar molecules, related to polar molecules, which of the statement is false? Centers of positive and negative charges are separated in the absence of external electric field. So this is about polar. So yes, centers are separated in case of, even if the external field is absent. Centers of positive and negative charges are separated in the presence of external electric field. Yes, it is also true. Does not possess permanent dipole moments. It should have mentioned molecular dipole moments. It does possess permanent dipole moments. So this is not correct. This statement is false. Ionic molecule HCl is an example of polar molecule. This statement is correct. I always give HCl and H2O as the example of ionic molecule. So this is a statement correct. So only this statement is false, but in my opinion possesses permanent molecular dipole moment, because in a crystal level total dipole moment, net dipole moment will be 0. Okay, so net dipole moment will be 0, but it does possess permanent molecular dipole moment. An electrician requires a capacitance of 6 microfarad in a circuit across a potential difference of 1.5 kilovolt. A large number of 2 microfarad capacitors which can withstand a potential difference of not more than 500 volt are available. The minimum number of capacitors required for the purposes. So if you remember, I have solved this question during my regular class, right? If you are following my regular class, I have discussed this question and even answered it. Also I said that I will be solving this question again during my PYQ session. This is little tricky question and the answer is not 3. Okay, now if you are wondering why it is not 3, you have to go back to my lecture and see that portion. But here I will solve it from the beginning. So first what we have to find that each capacitor, whatever is available to us. So we have a lot of more 100, 200 capacitors of this 2 microfarad. But it can, the maximum voltage that you can apply across is 500 volt. So this 2 microfarad capacitance is basically consist of capacitors of having maximum voltage of 500 volt. But our operating voltage is 1.5 kilovolt. Our operating voltage is 1.5 kilovolt. So how we can convert a 500 volt capacitor to 1.5 kilovolt? Okay, so this is the first question that we have to ask. So to do that, we have to know that when capacitors are connected in series, the potential differences gets added. the potential differences gets added. So when you connect them in series, the potential, total potential, it can now withstand 500 for this, 500 for this, and 500 for this. So the potentials will be added. So total potential now this combination can withstand is 1500 volt or 1.5 kilovolt. 1.5 kilovolt is 1500 volts. Okay, so this is the combination that we are looking for. Now our target capacitance is 6 microfarad. Is it 6 microfarad? No. So they are connected in series, but in case of capacitance, as I told you that the capacitance decreases when you connect them in series. When you connect them in series, the capacitance decreases. So this is C, this is C, this is also C. When equal capacitors are connected in series, the equivalent capacitance is given by C by N. In this case, C by 3. Okay, C by N is the equivalent capacitance when N number of capacitors are connected in series. Okay, now what is this value? 2 by 3. C is 2, right? This is the value given. So 2 by 3 is not 6, obviously. So now what we have to do? So we have achieved the voltage part. First part is done. So voltage part is done. Okay. So how can we now increase the capacitance? To increase the capacitance, we have to connect similar combination in parallel. We have to connect similar combination in parallel. But how many of them we have to connect in parallel? That number we have to find out first. Say we have connected N such combination in parallel, so that the total equivalent capacitance of this entire geometry is 6 microfarad. Okay, so this is the capacitance of one combination. Okay, one combination, two combination, three combination, N number of combinations. So what is the total capacitance of the combination? Total capacitance is N into 2 by 3. So when equal capacitors are connected in parallel, their capacitance increases by N times. Okay, when they are connected in series, it decreases by N times. When they are connected in parallel, it increases by N times. Okay, so this is given as 6. This is our target. This is our final target. So we have achieved that. So what is N? N equals to 6 into 3 by 2, that is 9. Okay, so we need N number of such combinations. So total number of combination that we require is 9. So 9 such combination, each combination having 3 capacitors. 9 such combination, each combination having 3 capacitors. So what is the total number of capacitor? Total number of capacitors will be 9 combination, each having 3 capacitors. So total number of capacitors that we need is 27. Total number of capacitors we need is 27. It is neither 3 nor 9. Okay, so you have to be very careful. This is a tricky question, and if you once you start solving such questions, then you will be perfectly ready for your KCET preparation. Okay, this is considered to be a difficult question. It's like above average question in KCET exam. So if you know that out of 60 questions, usually 40 questions are easy. Okay, 10 questions are difficult, 10 questions are medium. Of late in 2025, the number of questions in physics that I have seen, I found the same pattern. Okay, 40 questions are easy, 10 questions are difficult, 10 questions are not super difficult, but 10 questions are relatively difficult, and 10 questions are medium. Even medium questions can be answerable. Even difficult question can also be answerable if you are prepared, if you are ready, if you are managing your time properly. How to manage time is very, very important during the exam hall. Now let's see this question in the figure. So this question also I have solved in the class. in the figure, charge on the capacitor is plotted against the potential difference across the capacitor. The capacitance and energy stored in the capacitor are respectively. So energy stored and the capacitance of the capacitor. So here we can see that Q versus voltage is given. Q versus Q in microcoulomb. This is in microcoulomb, and voltage in volt is given. So this line represents 120 volt and 120 microcoulomb. This line represents 10 volt. Right. So this point is everything we know about this point. Right. So we know that Q is equal to C into V. So at this point, and also C is independent of Q and V. It only depends on the geometry. Now geometry is constant, so C must be constant. C is Q by V. So what is Q? Q is 120, V is 10, and remember this is micro, so it will be microfarad. So 12 microfarad. 12 microfarad is the capacitance of the capacitor. Okay, what is the energy stored? Energy stored formula simply given by, energy stored is given by half Q into V. So that is half 120 into 10 microjoules. Remember this is microjoules because the charge is micro, so energy will also be in micro. So it will be 60 into 10, that is 600 microjoules. So 12 microfarad, 600 microjoules. So this is the correct combination. Option B is our correct answer for this question. Now if you want to answer correct questions more often, and if you want to prepare for your future ambitions, JEE, NEET, KCET, and if you are looking for a perfect offline campus, then definitely Diksha has a lot of offline campuses. You can contact through the link given in the description of this video. Our representatives will contact you for any further information. Here is the rank list that we have achieved in KCET 2025 exam. So as you can see, these are the toppers, and this is our result in our Diksha offline campuses, where teachers will physically teach you during like a regular college along with your exam preparations. Okay. The figure gives the electric potential V as function of distance through 4 regions on x-axis. Okay. So here we have a diagram where voltage is given according to the distance, okay, on the x-axis. So you can see that the value is constant at 2 volt here. It increases to 4 volt when it moves by 1 meter. Then again it is remain constant for 2 more meters. Then again it decreases from 4 to 0 in next 1 meter. Okay, so this is the voltage changing. So they asked you which of the following is true for the magnitude of the electric field in these regions. Now magnitude of the electric field is asked, so we don't need to bother about the sign, right? First of all, you have to remember that electric field is given by minus dV by dx. As I said, negative sign does not matter over here. Okay, only dV and dx are important. So if you see that at region A and region C, the voltage is constant. Okay, so voltage is constant means what? dV is 0, ddx of C. So ddx of C means EA and EB both will be 0. Okay, EA and EB both will be, EA and EC, sorry, EA and EC both will be 0 because it's a constant voltage. Now voltage is changing at location B and at location D. Now which of them is greater? Okay, so EB is given by, what is the change in voltage? Change in voltage is 2. What is the distance? Distance is 1. So dV by dx, so it is 2. What is ED? ED, it is changing from 4 to 0. So the change in 4 and the distance is 1. So it is 4. So obviously ED is greater. So as I said, they asked you only about magnitude, so don't need to worry about sign. In fact, in case of sign also, if you consider, you will get the same result because EB will come negative anyway, those who are interested. So EC is equals to EA, so EA is equals to EC, and EB is less than that of ED. So if you have figured out the first point, you could have answered this question easily. Okay, because there is no trick in these options. Options are straightforward. So you figured out EA is equal to EC. This is not the same. So EA must be equals to EC. So you could have answered it even without knowing what is the relation between EB and ED. So this type of questions also come in KCET. Figure shows 3 points A, B and C in a region of uniform electric field E. The line AB is perpendicular and BC is parallel to the field lines. Then which of the following holds good? VA, VB and VC represents the electric potential at point A, B and C respectively. So let's see the diagram. So here we have, as you can see, that here we have point A, VA, point B, VB and point C, VC. Okay, this is the direction of the electric field point in this direction. So as we know that as we move in the direction of the electric field, the electric potential decreases. Okay, and along a line perpendicular to the electric field, it is an equipotential surface. In this case, it is an equipotential line. So the electric potential will be constant. So VA must be equals to VB. VA must be equals to VB, and both of them must be greater than that of VC because it is appearing first. Whoever is appearing first, they will have more potential. Whoever is coming next, they have less potential. So VA equals to VB and both of them are greater than VC. So this is the correct answer. Option D. A dipole of dipole moment P and moment of inertia I is placed in a uniform electric field E. If it is displaced slightly from its stable equilibrium position, the period of oscillation of the dipole. Okay, so first of all, you have to calculate what is the torque, initial torque, whatever is the initial torque which is acting on the dipole. It is given by P into E. Okay, it is given by P into E. Now if you displace it slightly, then you can show that this torque is basically I alpha is given by PE into delta theta. Theta is a dimensionless quantity, so dimension does not change, but you can show that. Okay, I am not doing it in this class. This is a little bit higher level. So from here, alpha is given by PE by I delta theta. Okay, so this question is easy if you know the theory. If you don't know the theory, if you have to do it from the scratch, then this is a very difficult question, even more difficult than a JEE main question. Okay, but theoretically, this is a very standard question because this is a very standard theory. So alpha is given by PE by I, and from here we can say that this is given by omega square delta theta, and from here omega square is given by PE by I, or omega is given by square root of PE by I. So what is the time period? Time period is 2 pi by omega, that is 2 pi square root of I by PE. Okay, so it is 2 pi I by PE. Also you can figure the answer if you, even if you don't know that time period generally represented by this equation 2 pi by omega. If you followed my JEE PYQs for the last chapter, there was a lot of question based on the time period. We solved this type of questions, right? So that's why I say sometimes it is good for you to solve some difficult JEE mains question. That gives you some clarity, some remembrance of the theories and equations and formulas as well. So T is equal to 2 pi by omega. So 2 pi has to be there. So 2 pi has to be there, and if you see the options, only one option has 2 pi. This one has 1 by 2 pi, not 2 pi. So 2 pi has to be there. From there you could have guessed the answer. This is the correct answer. Now let's move on to the next question. The difference between equivalent capacitances of two identical capacitors connected in parallel to that in series is 6 microfarad. The value of capacitance of each capacitor is. So this is a very easy question and answerable. Only thing that you have to know how to solve this question quickly. So here first of all, two identical capacitors, that is the first point of identification. You have to identify that both capacitors are connected, are identical. That means we will use the shortcut that I showed you. When two capacitors, identical capacitors are connected in series, what is the equivalent capacitance? So they are equal capacitance, C and C. So what is the equivalent capacitance? C by 2. Capacitance of any one of them divided by number of capacitors. Similarly, when they are connected in parallel, okay, so what is the shortcut? In this case, this is easy anyway. So capacitance C and number of capacitors. So in case of parallel, it gets added. In case of series, they gets divided, right? Now who is bigger? 2C, right? 2C is bigger than C by 2, right? So 2C minus C by 2, that value is given here. The difference means the difference between bigger minus smaller, right? So that value is given here 6. Now microfarad, again I am not considering here because C itself is in microfarad, so that microfarad will cancel from both sides. So microfarad we do not need to consider. So now just do the mathematics. 2 4C minus C equals to 6, or 3C equals to 12, or C equals to 4 microfarad. So microfarad will come at the end again. So correct answer is option A, right? So if you don't understand such kind of questions, you have to practice little bit more and have some trust in me. This is a very common question in KCET. This kind of questions are very common, right? I am doing it for a lot of years, and as you can see our results as well, right? Now let's move on to the next question. Two metal plates are separated by 2 centimeters. The potential of the plates are minus 10 volt and plus 30 volt. So we have two plates, okay, metal plates. One is at minus 10 volt, another one is at plus 30 volt, okay. The electric field between the two plates are. So this is also very common question. We have solved some questions, and by solving questions you develop the skill of how to solve this. Now what will be the direction of electric field? Electric field always points from higher to lower. You have to remember, electric field always points from higher potential to lower potential. Okay, so what is the value of electric field? Electric field is equals to minus dV by dx. Okay, so what is dV over here? Minus 10 minus 30. Okay, divided by dx is 2 centimeters, so that is 2 into 10 to the power of minus 2. So why I have done this minus 10 minus 30? Final minus initial. You have to remember this in your head and you have to repeat it along with me. Final minus initial. Most 99.99 cases it will be final minus initial. Okay, so minus will get common and it will cancel with this minus. So 30 plus 10, that is 40. 40 divided by 2 into 10 to the power of minus 2 or 20. Okay, 2, fine. So it will be 20. So 20 into 10 to the power of 2. 20 into 10 to the power of 2. So this minus 2 will go up and become plus. So it will be now 2000 Newton per Coulomb. Also you can write volt per meter. Whatever unit you are comfortable, both are same units. So 2000 volt per meter is given over here. So that is the unit of electric field. value and unit. Now there is another question, the equivalent capacitance between A and B is. So equivalent capacitance between this configuration A and B. So what is the equivalent capacitance over here? So we have to identify individual capacitors and then solve it. So if you see here, we will start with the easiest one. Okay, so this is the starting point, and as you can see here, we can see two capacitors connected in parallel, right? Just checking if you are listening to me or not, right? So if you get distracted, then your marks will also be poor. So you have to be focusing in the lecture. Okay, look at me. So 100 and 100, they are connected in series, not parallel. So if you are still thinking parallel, this is not parallel connection, this is a series connection. So 100 and 100 both are equal. So both equal and connected in series. So the equivalent capacitance will be 50, right? Two capacitors connected in series, equal capacitors, so divided by 2, that's why two capacitors. So now we have 50 over here, we have another 50 over here. Okay, this one, this entire thing is represented here, right? So 50 and 50 in series now, sorry, not in series, again they are in parallel now. So parallel means what is the equivalent capacitance of this combination? 50 and 50, both are 50, so 50 into 2, that is 100. So this is the equivalent capacitance of this combination. Okay, so we have now 100, here we have A, and here we have 50, here we have B. Now tell me how they are connected. How they are connected? Are they parallel or are they series? This is very interesting to identify. So each step of the problem you have to draw a inter-between steps. If you are doing it right now, that will help you up in future when you can solve this question in the diagram itself. Right now, maybe you are not capable of solving the question in the diagram unless you are already a brilliant student. Otherwise, if you are struggling to solve, like most of you, I know many of you sometimes struggle to solve similar simple questions. This is simple question, easy question. Okay, and if you are struggling like most of you are, then what you have to do, you have to do it step by step. Okay, so first you simplify this one, then you simplify this thing, then you simplify the entire thing. So this step by step diagram will help you to identify which part you are doing. So in fact you can draw that 50 over here also, but if you confuse and make that okay these three are in parallel, actually would be wrong. So these three are not in parallel. Okay, first you have to simplify these two are in parallel. Okay, so that's why they have given this diagram, so that you get confused in between and you fall for the trap. Okay, so these three are not in parallel, these two are in parallel, but here is a cut. As soon as there is a cut, you cannot say this is a parallel combination. So there is a cut means this is a series combination. So if you start from A, you can reach B through the capacitors directly. So basically if you stretch it out, it will be a single straight line. This is not parallel. If these 2 points are joined, then that might be in parallel, but because these 2 points are not joined, they are in series combination. So 100 and 50 are in series. Now I am going to teach you one more shortcut. I hope you learned that in your class 10th, that when two resistors are connected in parallel, two resistors connected in parallel, R1, R2, what was the equivalent resistance? R1, R2 by R1 plus R2, right? So in this case, capacitors, when capacitors are connected in series, two capacitors are connected in series, the equivalent capacitance is given by C1 C2 by C1 plus C2. Okay, C1 C2 divided by C1 plus C2. Okay, this thing is applicable for series combination of capacitors. So students often confuse and make mistakes by confusing resistors and capacitors. Just fit this in your brain. Capacitors and resistors are opposite in terms of formulas. Okay, there are a lot of other differences as well, but in terms of formulas, combinations, they are exactly opposite. Series, if this is series, then it will be applicable for capacitor resistance parallel combination. So this is how you have to remember it. You have to fit that in your brain, right? So because this is very common, even I made that mistakes when I was a student. Okay, series combination, by mistake I added them and found the answer was wrong, right? So you should not do that. You have to practice this again and again, and slowly, once you are at the end of your end of the year, you should be able to master it. Okay, so 100 into 50 divided by 150. So 100 cancels, 50, 3 5s are 15, so it will be 100 by 3 picofarad. Picofarad, right, or microfarad? Picofarad. So it will be 100 by 3 picofarad. Option D is correct, right? So you have to solve this step by step, and if you have any doubts, any questions, any comments, please mention that in the comment section of this video, right? A capacitor of capacitance C charged by an amount Q is connected in parallel with an uncharged capacitor of capacitance 2C. The final charges on the capacitors are. Okay, very interesting question. So capacitor of capacitance C. So we have a capacitor of capacitance C. Okay, charged by an amount Q is connected in parallel. First it is charged by an capacitance Q, charge Q. Okay, now it is connected in parallel with an uncharged capacitor of capacitance 2C. Now we are connecting another capacitor of capacitance 2C. Okay, so the final charges on the capacitors are, we have to find the final charges in the capacitors. First of all, what will you have to remember? So initially you have given charge Q, and because it is not connected to any other external source, the charge Q will remain constant. The total charge Q will remain same or constant. Okay, because conservation of charge. Now this charge will be redistributed. This charge will be redistributed. Some will be given to this C, some will be given to 2C. Okay, so you are eating apples. Okay, so your older brother or younger brother came and he said, okay, why are you eating alone? I also need some apple, please give me. He came, and but number of apple was still constant, right? So you have to share it from your own portion, right? So this is how this capacitor is connected, right? Now how can you find that? So finally you have to remember that in electrostatics, the one thing that is common in case of parallel combination, that is they will have same voltage. They will have same voltage. Once everything is done, whatever voltage is across this, same voltage will be across this as well. So both of the capacitors will have the same voltage. Suppose this one has now a charge Q1, this one will have a charge Q2. Okay, and also we know that Q1 plus Q2 must be equals to the original charge Q. Okay, now also the voltage across them is same. Now what is Q1? Q1 is CV, right? Q1 is CV. What is Q2? Q2 is 2CV. Okay, Q2 is 2CV, and that is equals to Q. So if you add them, you get 3CV equals to Q. Or from here you get V equals to Q by 3C. Q by 3C. So what is the charge Q1 now? Q1 equals to CV equals to C into Q by 3C, that is Q by 3, and Q2 equals to 2CV equals to 2C into Q by 3C, equals to q by 2q by 3. Now there is one more way to determine this. So in case of capacitors, you can determine the charge is given by the original charge multiplied by the capacitor C1 divided by C1 plus C2. This is another way to remember formulas. If you are good with formulas, you can do that. If you are good with concepts and if you want to solve it step by step, this is the way to do it. You have to understand that in parallel combination, voltage remains constant. The same voltage is applicable to both capacitors and the total charge is conserved. So from these two information, you have to solve it step by step. Now if you feel this question is difficult, it is actually even though it is easy in appearance, this question is slightly difficult. Yes, so if you are someone who feels this is a difficult question, this is actually a difficult question, not super simple. Okay, but if you with practice you can master this kind of questions and become a master of difficult questions. I told you previously as well, you have to practice. A particle of mass m and charge q is placed at rest in uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y. So something unexpected. This is a complete unexpected type of question. So we are talking about electric field, we are talking about mass, we are talking about charge. Suddenly they are asking what is kinetic energy, right? So this is a complete confusing question, but don't get confused. We know that work done is equals to in case because it's starting from rest, so work done equals to the final kinetic energy. Whatever work you are doing during that process, that same work will be converted into kinetic energy. They have not asked you to find the velocity, they only asked you the final kinetic energy. Okay, so what is work done? Work done is easy, force into displacement. Force into displacement. What is force over here? What force is acting on the charge? Force acting on the charge is Q into E. If you remember our previous chapter, force was given by Q into E, energy is given by Q into V, right? And what is displacement over here? Displacement is given by Y, so it is QEY, as simple as that, as easy as that. Okay, so this is the kinetic energy. So if you understand fundamentals properly, if your fundamentals are clear, KCET is going to be a very easy exam for all of you. A system of two charges separated by a certain distance apart stores electrical potential energy. If the distance between them is increased, the potential energy of the system is. So here we have a system of two charges, okay, and they are at a certain distance apart. Suppose Q1, Q2. Okay, now if the distance between them is increased, now whatever was the distance, say initial distance was R, okay, and you have increased the distance, say to capital R. So distance is increased. So what will happen to the potential energy? Obviously potential energy is K Q1 Q2 by R initially, finally it is K Q1 Q2 by capital R, right? So this is potential energy initially, this is potential energy finally. So obviously if you increase the distance, potential energy is decreasing. If you is increasing the distance, you are decreasing the potential energy, and that decrease is basically the work that you are doing. So whenever you are doing some work, that work is basically either stored or decreased in this case, because you are doing some work that decreasing the potential energy of the system. Okay, so it will be now there is one more point to remember over here, is that if the one charge is, both charges are positive, if both charges are positive or both charges are negative, if both charges are positive or both charges are negative, then potential energy will decrease. But if one of them is positive, another one is negative, if one is positive, another is negative, then there will be a negative sign coming over here. Q1 or Q2, one of them will be minus, right? So in that case, potential energy will increase. So that is also very careful. You have to be careful. This is also a simpler question, but not super simple. Okay, it may increase or decrease based on the sign of the charge, based on the signs of the charges. Okay, so if one of them is positive, one of them is negative, then the potential energy increases. If both are positive or both are negative, so for similar charges, potential energy decreases. For opposite charges, potential energy increases. A mass of 1 kg carrying a charge of 2 coulomb is accelerated through a potential of 1 volt. The velocity acquired by it. So mass is given 1 kg, charge is given by 2 coulomb, and it is basically passed through a 1 volt of potential difference. So what is the, first of all, what is the potential energy that it is you are giving it to it? So potential energy is given by Q into V. Potential energy that you are supplying to this mass, the potential energy that you are supplying to this mass is Q into V. Now once it is out, suppose this is the system, you have kept a 1 volt potential difference over here, okay, and you send that mass through this. Now once it is out of this field, this entire potential energy will be converted into kinetic energy. That is half m v square. You are asked to find the velocity. So this is the potential energy that you are supplying, and once this potential energy is completely, once this object is completely out of the system, there is no potential energy acting on it, so no potential is acting on it, so potential energy will be 0, but there will be some kinetic energy, and conservation of energy states that this potential energy has to be converted into kinetic energy. From there we say V equals to 2Q capital V divided by M. Okay, this is the equation. If you put the values, 2 into the charge is given 2 coulomb, the voltage is given 1 volt, the mass is given 1 kg, so it will be 4 meter per second. 4 meter per second, this is V square, sorry, 4 per meter square per second square. So what is V? V will be 2 meter per second. Okay, V will be 2 meter per second. Correct answer is 2. Okay, very easy. Next question, the work done to move a charge on an equipotential surface. This is a very common question. Now this was KCET 2018. Now this question is coming in your board exams MCQs. This is this type of question you can expect, not expect in KCET, but you can expect this question in your board exam MCQs, which is very important for board exam MCQs. This is 0, right? Work done to move a charge in equipotential surface is 0. Two capacitors of 3 microfarad and 6 microfarads are connected in series. A potential difference of 900 volt is applied across the combination. They are then disconnected and reconnected in parallel. The potential difference across the combination is. So first what we have two capacitors connected in series and applied a voltage of 900 volt. Okay, so this is C1, this is C2, the values are given. So this is 900 volt. Okay, this is the system. Now once everything is done, now you disconnected them. So suppose this one has some charge Q1, this one had some charge Q2. Okay, now once you connect them like this, now this is a very difficult question, not super easy, but I will try to make it as easy as possible. Now what happens when you connect them in parallel, okay, the charges, whatever charges they gained during this process, that will change. Okay, because the voltage drop across them was different. Now once you connect them back, okay, now the charges will redistribute so that the voltage across them is constant. Voltage across them in parallel combination, voltage is always constant. Now because this is a series combination, the charges on both capacitors will be same. Okay, even though initially I mentioned that charges are different, actually they are not. Charges are same. Both capacitors will have same charge. Also, not only these two capacitors, but their equivalent capacitor will also have the same charge. Okay, very important to understand that this is the trick, this is the shortcut trick. Otherwise you can use individual analysis and calculate Q, and from them you can solve it, but whatever method I am using is the shortcut, most easy way to answer such type of questions. It might come in your KCET exam as well. As I said, this is not super easy, this is tricky question. From my experience I can tell you, but this type of questions are very common as well. So C1 Q, C2 Q, both have same charge. Now what is the equivalent over here? C equivalent will also have the same charge Q, and not only that, it will also have the same potential 900 volt. This is for C equivalent, right? So C equivalent, both of them will have C equivalent will not only have 900 volt, it will also have the charge Q. That's why it is called equivalent, right? Now we calculate that C equivalent is, first of all we will calculate what is C equivalent. Series combination C1 C2 by C1 C2 by C1 plus C2. Okay, so it will be 3 into 6 divided by 3 plus 6. That is 18 by 9, that is 2 microfarad. Anyway, microfarad does not matter, but as I am used to, I am writing this. Now the voltage across that is 900 volt. So what will be the charge? Charge Q will be equals to 900 CV, 900 into 2 microfarad, that is 1800 microcoulomb. Anyway, I am keeping it like this only. Microcoulomb, I am not adding it. So 1800 microcoulomb is the charge on the equivalent capacitor. Okay, so what is the charge of this capacitor? 1800. What is the charge of this capacitor? Same 1800. Now you have to realize this fact that both the capacitors individually will have this 1800 microcoulomb. Very important to understand this, even though it is for equivalent capacitor, but when you come back to the original circuit, both of the capacitor will have the same amount of charge, and this question is based on the conservation of charge. Okay, so both capacitors will have the same amount of charge. Now when you connect them in parallel, what is the total charge of the system? What is the total charge of this parallel system? The total charge of this parallel system will be twice of Q. Twice of Q. Why twice of Q? Because each of them has the same charge. So when you are connected them in parallel, this charge will be redistributed, but total charge of the system will be 2Q. Very, very important. So if you don't understand this step, please mention that in the comment below. Maybe I will try to answer you either through chat or maybe in a future video. This is a very interesting and important part. Right, so total charge of the system is 3600. Now again, the trick that we used over here, we will use the same trick over here. We will try to find the equivalent capacitance in parallel combination. So what is the equivalent capacitance in parallel combination? C1 plus C2, right? C1 plus C2. So equivalent capacitance in this case will be 3 plus 6, that is equals to 9 microfarad. Okay, now we will apply the law. Q equals to CV. So this is, say, C equivalent dash. Okay, previous one was C equivalent, this is C equivalent dash into V, and we are trying to find what? We are trying to find this voltage. Q total 3600, C equivalent dash 9 right? So V, so this is say V dash is equals to 3600 divided by 9, that is 400 volt. So the correct answer is 400 volt. Okay, I surprised they didn't give any 900 volt answer. Okay, because they will see that most of the students will fall for 900 volt answer. Okay, if I was a paper setter, I would have given 900 volt as well, right, to make you confuse the most. So first step is to find the charge, then once they are connected in parallel, identify what is the total charge of the system, and then again find equivalent and find the voltage. Let's move on. A system of two capacitors of capacitance 2 microfarad and 4 microfarad is connected in series across a potential difference of 6 volt. The electric charge and the energy stored in the system are. Now this is very easy question. Two capacitors connected in series and the voltage is also given, and they asked you the total charge and total energy. So how to solve this? Don't solve it individually, that will be painstakingly long and difficult. So 2 and 4. So what we will be doing, just like whatever we have done in your previous question, we will find the equivalent capacitor, and then we will just find the whatever charge is stored in the equivalent capacitor. Okay, then we have to multiply it by 2. Right, total charge stored will be twice of that, and we will calculate the energy as well. Energy can be calculated using any one of them. Okay, no, not an issue. Okay, so this is V. So first we will calculate the equivalent capacitance. Equivalent capacitance is 2 into 4 divided by 2 plus 4, that is 8 by 6, that is 4 by 3. So 4 by 3 is the equivalent capacitance. So what is the charge stored? So Q equals to C equivalent into V. V is given 6 volt. So this is 4 by 3. Sorry, no, not this is not 4 by 3. This is we are trying to find out. So Q equals to 4 by 3 into 6. So it will be 8 coulomb, 8 microcoulomb. Okay, 8 microcoulomb. Now this is the equivalent charge on one of the capacitor. Okay, now remember that this is the charge on one of the capacitors. So total charge stored in this case will be, again, total charge stored will be 8 into 2, that is 16 microcoulomb. Now what is the energy stored? Energy stored, you just need to apply the whatever energy stored in the equivalent capacitor, the same amount of energy will be stored in the system as well. Okay, so the energy stored will be given by half Q into V, right, for equivalent capacitor. So half into Q is given by 8 and V is given by 6, so it will be 24. Okay, 24 microjoules. Now in this question, the total charge stored in the system is given incorrect. This should be 8, not 8, this should be 16 microcoulomb, or they could have asked what is the equivalent charge stored, then it would have been correct. Okay, this was a bonus question in that particular year of 2017. So this question is a bonus question. Okay, so you have to understand that we kept the question paper as it is without altering it. So this will be the total charge stored, because Q, both of the capacitor will store QQ charge. So total charge stored will be Q plus Q. Very important to understand. 2 point charges, A equals to plus 3 nanocoulomb and B equals to plus 1 nanocoulomb, are placed 5 centimeter apart in air. The work done to move the charge B towards A by 1 centimeter. So we have two charges, okay, A and B. Okay, the initial distance is 5 centimeter. Okay, this one has a charge Q1, this one say has a charge Q2. We will put the values later. Now if you take, move the charge B towards A by 1 centimeter, that means A is fixed, what you have done, you have moved the charge B by a distance 1 centimeter, okay, towards A. So now what is the new distance? The new distance will be 4 centimeter. The new distance will be 4 centimeter. Now what is the initial potential energy? The initial potential energy of the system is, K Q1 Q2 by 5 into 10 to the power of minus 2. Okay, so Q1 Q2 I am not putting it right now, but I am putting the distance, that will be easier for me. And what is the final? Final will be K Q1 Q2 by 4 into 10 to the power of minus 2. So what is the work done? Work done is basically change in energy, and change means final minus initial. Remember, always change is final minus initial. So it will be K Q1 Q2 by 10 to the power of minus 2, everything will be common, it will be 1 by 4 minus 1 by 5. So to 5 4 the 20, 20 and 5 minus 4, so it will be 1 by 20. Now let's put the values. So K is 9 into 10 to the power of 9, Q1 is 3 nanocoulomb, Q2 is 1 nanocoulomb, and this is 10 to the power of minus 2, and this is 1 by 20, so this will be 20 in the denominator, right? Now just 10 to the power of 9, 10 to the power of 9 cancels, and you can cancel this as well. You get 10, you get 1.5. Okay, so 1.5 into 9, how to do that? 9 into 1, 9, 9 into 0.5, 4.5. You add them, 13.5. So it will be 13.5 into 10 to the power of minus 2, 10, minus 1. Minus 1 goes up, becomes plus. So minus 9 plus 1, that is minus 8. Okay, 13.5 into 10 to the power of minus 8. So if you see the answer, you will identify there is only one possible answer. How to get here? If we remove the decimal by one place, then we can decrease the 10 to the power by 1. So 1.35 into 10 to the power of minus 7. So even if your first answer does not match with exact values given in the question, double check your answer, that if you can shift the decimal by 1 or 2 points, and if you can match the answer, that is very, very important. Now let's see this question. The minimum value of effective capacitance that can be obtained by combining 3 capacitors of capacitances 1 picofarad, 2 picofarad and 4 picofarad. So minimum value. So if you remember my lecture, I told you that minimum value is obtained only when capacitors are connected in series. So if you connect 3 capacitors in series, then the minimum capacitance you will get. You will get always the minimum value is possible when they are connected in series. Okay, no other combination is allowed. So what is the equivalent? 1, then we have 2 and we have 4. So what is the equivalent capacitance? C, 1 by C equivalent equals to 1 by 1 plus 1 by 2 plus 1 by 4. So it will be 4 and 4 plus 2 plus 1. So it will be 7 by 4. Now remember that this is 1 by C equivalent. You have to take reciprocal of that. That is, it will be 4 by 7. So 4 by 7 picofarad is the correct answer. Option B is correct answer. So this one also I have observed students make mistakes. They directly see it and they answer 7 by 4. This is not the answer. You have to take the reciprocal of that, and 4 by 7 will be the answer. So nature of equipotential surface for a point charge is. So nature of equipotential surface for a point charge. It will be ellipsoid with the charge at foci. Point charge, the it will be equipotential surface will be a sphere. Always it will be a sphere. 2-dimensional can be circle, 3-dimensional it will always be the sphere, and the charge will be at the center. Sphere with charge at the center of the sphere, so it will always be a sphere. Okay, now there is a homework question for you. For that you have to download today's lecture PDF. If you download the lecture PDF, you will find, I think, 4 homework questions at the end of the lecture. Do download it and try to solve them and let me know your answers in the description, in the comments below. Right. Also, if you have not yet subscribed to our channel, please don't forget to subscribe, and please give it a like if you like this video. I'll be back with the JEE PYQs next. Till then, bye.